My name is Ramesh Kumar Singh, and what we'll be talking about is ultra high speed micro machining center and the process. So we know that there is a global increase in demand for miniaturized products. So there is smaller products required in biomedical devices, in electronics, in defense applications, in micro molds, in jewelry. So there are a host of applications where we require small parts and small features. Now, traditionally for electronics application, people have these lithography based methods which are used for microscale machining. But now, since we have to do it for various other materials, not only silicon, and traditionally these processes evolved for silicon processing. So they are limited in the shapes they can create and the materials they can process. On the other hand, mechanical micromachining has been there for a while, and at macro and meso scale we can create free-form features in wide range of materials using traditional machining. But if you want to scale down the process, scale down the micromachining process, there are various challenges. The first challenge is that your tool is very small. We'll show you the machine and the tools in a little bit after this introduction, but the tool is, say, in fact it can be 25 microns, which is 1/4 of the size of human hair. Now if you have a tool that small, its stiffness is very low. And now if we use those tools for machining, those tools are prone to failure. So if you want to use those machines, you have to reduce the cutting forces drastically. And to reduce the cutting forces, you have to use very high rotational speeds. So traditionally, if you look at other machines which are used, they run for 3000 RPM. But these machines will have to now run for 100,000 RPM, 1 lakh RPM, these machines will run. So the general challenges, both on the machine design side for using these kind of small tools, and also on the process science of the process is also very complicated. So that's what we are trying to do in this process. Now what I will do is, I'll actually show you how we address that. So the way we address that thing is, to reduce the forces, we used very high rotational speeds, and these high rotational speeds basically make the machine cut very small material at a given time, and that's how we manage the process. Now the problem is that we have a very small stiffness tool and we go at very high rotational speeds, and these things actually make the tool prone to vibration. So we need a lot of science also to make sure that the tool vibration does not occur. So with this, let's go and see the actual machine in operation, and we'll talk more about it when we go to the machine. So this is the ultra high speed micro machining center, conceived, designed and built in the machine tools lab at IIT Bombay. This is one of the most precise machines designed and indigenously built in India. So now I'll talk about the structure here. So the structure of the machine is made of granite. This granite is very stable and it does not have any vibration, so it's very good vibration damping capabilities. And if you look at the structure, there is a slot here and rib. This slot and rib structure makes the machine very stiff, and also it has very good dynamic properties. Any vibration is dampened very fast. So after the structure, one of the most important parts is the actuation stages. This is X and Y stage, and this X and Y stage are precision stages driven by ball screw, and it has sub-micron resolution and micron level accuracy. So one of the most important parts of this machine, in fact the heart of the machine, is the Z stage. And if you look at the Z stage is a linear motor stage, and its resolution is 5 nanometers, and this is what gives this machine unprecedented accuracy. And the entire dead weight is actually counterbalanced pneumatically, so it gives very precision location for this machine. You can precisely cut features of very accurate size. The other important thing is the spindle. The spindle is an electric motor which is controlled by a variable frequency drive. The maximum speed of this spindle is 1,50,000 RPM, and it's a very precise spindle, and the run out is less than 2 microns right at this tool. So this is one of the smallest tool which we use in this machine. This is less than 50 microns, almost 1/3 of a human hair, and we can use these kind of small tools to create features which are very small. Let me show you some of the features which we have. So this is one of the examples. We can create holes which are about 25 to 50 microns as shown in this thing. This is on titanium. which is extremely difficult to machine. So we can create small features in super hard materials. So this is one of the other examples. This is a micro mold for a microneedle array. So this microneedle array can be used for making biomedical implants, which will be used for painless vaccination. And then with these machines, we can also create various complex geometries of microfluidics. So you can create very complex channels if you would want to have some microfluidic devices. So this is one of the other applications of this high-speed micromachining center.
So currently we are making a straight rectangular slot on the system. So we are using titanium Ti6Al4V alloy, so which is widely used in aerospace and biomedical applications. So the tool material is tungsten carbide. So we are using a 500 micron tungsten carbide end mill, and we are operating at 25,000 RPM. So the technology has wide range of applications. So along with micro hole fabrication, micro needle array mold for painless drug delivery, and applications in microfluidics. So this process can also be implemented to generate micro scale masks for lithography. Another application of the process lies in the domain of watch and jewelry manufacturing. So different kind of miniaturized jewelry patterns and designs and aesthetic features can be generated on the components using this technology. In the current time where everything is transitioning towards the digitalization, so we can generate micro scale QR codes using this technologies. So these micro scale QR codes can be printed on the jewelries and ornaments, and they gives access to a personalized memories of person, let it be photos, videos or text messages through a web interface, which is another domain for this application. So to summarize, the process has a wide range of applications ranging all the way from micro hole fabrication all the way to a digitalization of the memories, and we are confident that this will give a boost to the Atmanirbhar Bharat, which is our ultimate goal of the country. And if you have any queries relating to research or any commercial requirement of the machine or the features, or you want some products to be manufactured, you can contact Micromac Innovations Private Limited, which is a startup, and they will be happy to provide you the best service and quality. Thank you.